Angles and radian measure of a circle. This video will help you write positive and negative angles in standard position, identify angle measures in both degrees and radian measure, and identify coterminal angles. Angles in standard position. Let's take a look at a definition here. Angles in standard position have the vertex at the origin, and the vertex of the angle is right here. So we got a vertex at the origin, and have an initial side on the positive x-axis. So whenever we're measuring angles here, we always start with our initial side of the angle right on the x-axis. Going from the origin, traveling out to the right here. Traveling out to the right there. Okay, so that's our initial side. Terminal side then is the end of the angle, and that's what you can see I have listed right here. So this angle initiates here on the x-axis, opens up, and goes to this terminal side of the angle. Angles in standard position always start here at the x-axis. If they're going to be positive angles, then they open to the left, like this one. If they're going to be negative angles, then we again start with our initial side in the same spot, but then we open to the right for a negative angle. And you'll see this labeled a lot for angles as we're talking about angles. This alpha symbol and this beta symbol down here to label different ones. You know, it's kind of like A and B, but we use Greek here, alpha and beta. All right, so now I got a couple questions for you here. In standard position, draw a positive 45-degree angle and a negative 135-degree angle. So go ahead and pause your video player now and answer these two questions. When you get done, hit play to see how you did. All right, so we're not going to be perfect here, but hopefully you get in the right ballpark here. So I'm thinking first a positive 45-degree angle. So I want to draw my initial side, starting at the origin, traveling out to the right. And now I want to go 45 degrees positive. Remember, positive angles open to the left. So remember, this would be a 90-degree angle there, right? If I went from the x-axis and travel up to the y-axis. So we want to go half of that to get 45. So there's a positive 45-degree angle. All right, let's take a look now at the next one, which is a negative 135. Well, whenever we're working with these angles, positive or negative, we kind of want to have these starting points or base points as we travel around. And I think as we travel around, either positive or negative, you know, 90, these increments of 90 will really help here. So we got 90, 180, and then if I add another 90 to 180, I get 270, and then all the way around 360. So that really helps here as we're figuring things out. 90, 180, 270, and then 360 degrees. So we want to kind of think of this 135-degree angle in terms of maybe starting out with one of these angles. Like I would say, well, look, 90 degrees goes into that, so I could think of this 135 as a 90-degree angle plus what here? Well, if I add 45 to 90, I'll get 135. Thinking it through this way helps us identify these locations on the circle and these angle locations, and that's going to help a lot both for, this is degree measure right now, and we're also going to take a look at radian measure here in just a second. So let's see, so 90 plus 45 is going to give us this 135, so that will help me graph this. So I'm going to go negative now, a negative, so I'm going to travel in the negative direction, first 90 degrees, and then I'm going to travel another 45. So here's the terminal side of my angle. Here's the initial side of my angle, and let's erase this 270 here so it doesn't get in the way. We'll erase that too. And then we said this was a negative 135-degree angle. Radian measure of a central angle. And all central angle means is that we are going to be centered right here, the vertex at the origin. So let's take a look again at another definition here. The radian measure of an angle is the arc length divided by the radius r of the circle. So arc length we're going to define as S here, and the radius is R. In arc length, all that means is if I got an angle here, and this angle is theta, we call that angle theta. If we want to know the measure of theta in radians now, all we do is we take this arc length, this distance from the x-axis all the way up to the terminal side of that angle. So that distance around the circle, we're calling that S, the arc length, and then we divide it by the radius r to get the measure of theta in radians, and that's what we have here. Theta is the arc length divided by the radius. Okay? So radian measure, what it really does, and I got a little call out there for it. Radian measure measures with the radius. It tells us how many radii long the arc length is. Because remember, if we do a division, we're asking how many of these radii fit into this arc length. Could be a whole radius, it could be more than a radius, or it could be less than a radius. But that's how we measure in radian measure. And it makes sense, you know, we want to be consistent. If we're talking about measuring with the arc length, you know, if I have a very small circle here, and I look at an angle, let's look at the same angle here. My circle's not perfect, but you'll get the idea. Let's look about the same angle here. If I take a smaller circle, notice this distance S is now going to be smaller. But also notice this, that as the circle gets smaller, so does the radius r get smaller here. So this ratio will always work out evenly, this radian measure. If I have a small circle or a medium circle or even a large circle, the radian measure will still be consistent for the angles, because the smaller the circle, the smaller the arc length, but also the smaller the radius, and vice versa. The bigger the circle, bigger the arc length, bigger the radius, but that ratio will always be consistent and give us a consistent measure with this radian measure. So this is another way to measure angles in a circle. We've got degrees, which most of us are familiar with. This is another measure, radian measure, meaning we're measuring with the radius here. We use this a lot in trigonometry. So it's important to get a sense and a feel for the measures around the circle in both degrees and radians. All right, now let's take a little closer look now at both the degrees, measuring degrees in a circle, and also measuring with radian measure. So if the arc length of the entire circle, so instead of just having a small piece of an arc length here like we had in that last one, we are going to go all the way around the circle. So starting here and then traveling all the way around. That would be an arc length of the full circle. Well, a full circle, the arc length of a full circle, all that is the circumference of the circle. And remember, we find the circumference of the circle either pi times diameter or 2 pi r, because you can see that twice the radius does give us the same thing as the diameter. So if we look at this one right here, this 2 pi r, that would be the arc length of an entire circle. Well, if we used radian measure there, remember radian measure is the arc length divided by the radius. And so if you take a look here, the radian measure would be the arc length, which is 2 pi r, circumference, divided by r. Notice the r's divide out nicely, and they tell us that the radian measure of the entire circle is 2 pi. Well, if we know that all the way around is 2 pi in terms of angle measure, we also know that all the way around in degrees is 360 degrees. So these two, in radian measure, 2 pi is the same as 360 degrees all the way around the circle. So that's what I've written right here. 2 pi in radians is the same as 360 degrees. Well, if I divide both sides by 2 here, then I can see that pi in radian measure over here is equal to 180 degrees. And this little equality will help us convert now between degrees and radians, or radians to degrees. Okay, before we do that though, let's take a little stop here. So 1 full revolution, a quarter of a revolution, an eighth of a revolution. I'd like you to identify both degrees and radian measure of those things. So go ahead, pause your video player now and answer these 3 questions. All right, well, question 1 I think I already answered for you. So if we go 1 full revolution, start here and go all the way around the circle back to here, we know that that is 360 degrees. we also said just a second ago, a long explanation, that that is also 2 pi radians. So those are the answers to question 1. All right, question 2 here, 1/4 of a revolution. So we're just going to travel right up to there. Well, degrees was probably pretty easy on that. That's 90 degrees. Let's find out now what that would be in terms of radian measure. Well, we know that all the way around the circle is 2 pi. Notice this is 1/4 of the way. So if I took 2 pi times 1/4, it'll give me 2 pi over 4. It's going to give me pi over 2 for radians. So 90 degrees is the same as pi over 2 in radians. All right. Next question, 1/8 of a revolution. So 1/8, this was a quarter, so 1/8 is going to be right to there. All right. And we know that if we took half of 90, that's going to be 45-degree angle. Now let's do the same thing. 1/8 of a revolution, well, all the way around the circle is 2 pi. Times 1/8, we'll get 2 pi over 8, which would just be pi over 4. So 45 degrees or pi over 4 for our radian measure there. All right, let's take a look at another question here. And what I want you to do is I want you to go around and identify all these locations. So I've drawn a circle here, drawn our circle here, and these are the important locations that we've decided. So, you know, if we go around the circle, I think it's easiest to see, and it's important to see how we've kind of split this or divided this circle up. So the first thing we did is we took this circle and we cut that circle in half. And if you travel by half here, we will get, you know, half of the circle, which would be 180 degrees, or pi, that would be halfway, and then travel all the rest of the way around, 360 degrees and 2 pi. So that's one way we've divided it here. And I think it's easier. Okay, so now we're going to take a look at question 4. And in question 4, what I want you to do is go around this circle here and label all of the degrees and radian measures around the circle. Before we do that, though, let's kind of talk about how the circle is split up. And this is how we split up circles in trigonometry. Pretty soon we're going to study a circle which is called a unit circle. And all that means is we have a circle with a radius of 1 unit, or a radius of 1 here. And these are the important locations that we use in trigonometry. Let me kind of show you how we've divided it up, and I think that will help you label these measures. So I think the first thing to look at is we've divided this thing into quarters here. So you notice if you travel around here, there's a quarter, 2 quarters, 3 quarters, 4 quarters, all the way around. So those are kind of our quarter ones. Those are usually the easiest ones to identify. The next thing that we've done with these quarters is we cut each of those in half. So you can see here, this is if I take this quarter and I cut it in half, I'm going to get this one right here, which we've already talked about a little bit. It's our 45-degree angle, right? And so notice I take each of these quarters and cut them in half, and these would be then 1/8 of a way around the circle. So look, if I travel by 1/8 here, this would be my first 1/8, my second 1/8, my third 1/8, fourth, fifth, 6, 7, 8 1/8 all the way around the circle. Okay, and so I think that's important to see. First, we divide it into quarters. You know, 1, 2, 3, 4 quarters. Then we cut those in half to get our 1/8. Now we don't cut those in half again like we do on a ruler to get a 16th here. We kind of jump and go to some different increments. So you notice the other thing that we can do here is we've cut each of these quarters into thirds. So if I just took this first quadrant here, you know, the first thing I did is I said, okay, well, let's cut it in half. And then that got us our 45-degree angle. The other thing that we did is we cut this distance into thirds. So here's 1/3 of it, 2/3 of it. And these increments are all the same. So this one is the same as that one, is the same as that one. So we're cutting these things into thirds here as we go. And let's get rid of the 45-degree angle here. And so a third of a quarter, these are actually twelfths of a circle. So this would be 1/12. Remember when we did the quarters, those were eighths. 2/12. 3/12. Notice 3/12 is also equal to 1/4. That's where we're up here at this spot on the circle. So really what we've done now is we cut this thing into 12ths. And if we go around by these 12ths, you can see these marks. Here would be 1/12, 2/12, 3/12, 4, 5, 6/12, halfway, 7, 8, 9, 10, 11, 12. And so that's how we make this circle and this unit circle in trigonometry that we use. First we, cut it into quarters. 1, 2, 3, 4 quarters. Then we cut it into eighths. 1, 2, 3, 4, 5, 6, 7, 8. Then we cut it into twelfths here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way around the circle. So I think that's going to help you out as we're identifying these things. Remember, we've got the whole distance around in degrees is 360 degrees all the way around, or 2 pi. Knowing that information and knowing how we cut this thing into these pieces, you'll be able to label all of these pieces. So go ahead now and pause your video player and fill in as many angle measures in degree and radians as you can. Hit play when you're done to see how you did. All right, well, let's start with the quarters. And we'll start with those in degrees. So here, we had started out with 0 degrees. And then we travel our first quarter, which would be 90 degrees. And then I'm going to travel another quarter, which would add on another 90 degrees. So I'd be at 180 here. And then add another 90 degrees for the next quarter. I'd be at 270. And then all the way back around, I get 360 degrees. Okay, let's talk about those now in radians. Remember, all the way around is 2 pi. So if all the way around is 2 pi, halfway around would be just pi. So I'm traveling from here all the way over to there. That would be pi. Well, this travel here would be half a pi. Well, that is just pi divided by 2. That's half a pi. So notice, let's start counting by these pi over 2's. Just like I counted by 90 degrees here to work my way around, let's count by pi over 2. So I'd say, all right, here's pi over 2 for my first one. And then another pi over 2. Notice if I take pi over 2 plus pi over 2, it's going to give me pi because 2 pi over 2 is equal to just pi. So pi over 2, 2 pi over 2, which is pi. Then I want to add another pi over 2 to that. Down here, well, let's think about it. Here I said right at this point here, I was 2 pi over 2. Right? If I add another pi over 2, it'll be 3 pi over 2. And then if I add another pi over 2 to that, it'll be 4 pi over 2. Well, it's the same as 2 pi here. So then I'll get 2 pi there. All right. So that's kind of travel in the quarters now. If you weren't making a lot of progress before, and now that you've seen me go through and kind of count by pi over 2's, because that's what each of these quarters are, is a pi over 2, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. You can think about these the same way. We know this distance is pi over 2. This distance here will be half of that. So half of pi over 2 is pi over 4. And so what you can do now is you can go through, just like I did with pi over 2, and count by pi over 4 every quarter. And I think if you haven't filled this in or you made some mistakes already, let's go ahead and pause your video player again and go around now and count by pi over 4's to fill in those radian measures. While you're doing that, of course, I'm assuming you got the degrees right. That's 45 degrees, and you can just count by 45 degrees, adding 45 degrees every one of those increments you go. But if you were having trouble, pause it again. If not, we'll just keep going. All right, so I guess we'll start with degrees here for this quarter, eighth of a circle. This is an eighth of a circle here. So 45 degrees, every time I move this distance or this arc length here, I'm going to get another 45 degrees. So we got 45, 90. 90 plus 45 is 135. 135 plus 45 will bring us to 180. 180 plus 45 will get us to this next spot here. So that's 225. 225 plus 45 will bring us to 270. And if I add 270 plus 45, that's going to bring me to 315. And then 315 plus 45 will bring us back to 360. Okay, so that was going through by degrees. Now let's go through and count by pi over 4s, because that's what this distance was in radians. So I'd have 1 pi over 4, 2 pi over 4. Well, 2 pi over 4 is just pi over 2 when I simplify that fraction. So 2 pi over 4, 3 pi over 4. 4 pi over 4, well, 4 pi over 4 is just simplifies down to pi. So, but that's good to know that it's 4 pi over 4, because then here will be 5 pi over 4. And then here, 6 pi over 4. Well, 6 pi over 4 simplifies down to 3 pi over 2. But it's important to know this is 6 pi over 4, so this will be 7 pi over 4. And then traveling one more eighth here, we would get to 8 pi over 4, which is just 2 pi. Okay, again, if you're rolling along, keep watching the video. If not, if you had to make some corrections now, go ahead and stop it now. And now we're counting by 12ths here, right? So let's see, if I took this quarter of the circle here and I divide it into 3 equal parts, 1, 2, 3. I take this 1/2 and I'd say, all right, 1/2, I'm going to divide you into 3 equal parts, which is the same as multiplying by 1/3. So that's going to be pi over 6. So every one of these jumps here, this 12th of the circle, is pi over 6. So, 1 pi over 6, 2 pi over 6. If you haven't labeled those yet, go ahead now and go through and count by pi over 6 through and label the remaining spots on the circle. All right, let's take a look. So here would be pi over 6, and then if I jump here again, that would be 2 pi over 6. Well, 2 pi over 6 can simplify down to pi over 3. So 2 pi over 6, 3 pi over 6, well, that's just pi over 2. 4 pi over 6, let's see, 4 pi over 6, that's just 3 pi over 2. So there's 4 pi over 6. Here's 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. Well, 8 pi over 6 reduces to 4 pi over 3. Notice the same patterns happening here. The first one stays pi over 6, and the next one always simplifies down to something over pi over 3. So that's consistent. So let's see, here we were at 8 pi over 6, 9 pi over 6, which simplified to 3/2, and then 10 pi over 6. 10 pi over 6 will reduce to 5 pi over 3. And then 10 pi over 6, 11 pi over 6. For that one there. And I've got quite a mess here. I've got this all written out here on a nice unit circle so we can take a look at this together. So I'm going to scroll down so you can see that. But that's good to work on the thinking as we go around the unit circle, because in just a second we're going to be finding coterminal angles, and you're just going to kind of work your way around the unit circle, either counting by degrees or counting by radians. But let's look at a nice clean picture of this. And so you can see inside of this unit circle here, which we're going to be studying in the next unit here, it's got both the radians on the inside and the degrees on the inside. So, and these again are all simplified down. I think it's important the way I was showing you to count around there, because that's how we figure it out. But once we figure it out, we simplify these things down. So take a look now and compare all of your measures with these both degree and radian measures that are in there. If you get one wrong, if you got one wrong, try to go back and recount it just so you can get to the correct location there, because moving around the unit circle the way I was counting it, again, is really, really important. Okay, now we're going to take a look at question 5 here. And this is where we're going to find coterminal angles. So angles that have the same initial and terminal side are called coterminal angles. Okay, so let's say I have one angle here, and we'll start with a nice easy angle. Let's start with a 90-degree angle. So if I start initial side here, terminal side here, there's a 90-degree angle. Now, since we're working on a circle here, I can travel more than one time around the circle and find another angle that terminates at the same location. So notice, if I travel to 90 degrees, I get to this location here. I could also travel all the way around the circle and come back up to that same location. Well, let's figure out how far that is. All the way around the circle would be 360 degrees. And then I'm adding another 90 degrees to that. So let's see, that would be 450 degrees. So what I figured out now is that 90 degrees and 450 degrees are coterminal angles. And so we say coterminal for short, meaning they terminate at the same location. Okay, so we're going to be working in trigonometry here with angles that are much greater than 360 degrees or much greater than 2 pi if we're talking about radians. And it's going to be important to kind of dial that back to the original just going around the circle one time. In other words, it's going to be important for us to find coterminal angles that are between 0 and 360 degrees if we're talking about degrees, or between 0 and 2 pi if we're talking about radians. And so that's what we're doing here in question 5. So find a positive angle less than 360 degrees if we're talking about degrees, or less than 2 pi if we're talking about radians, that is coterminal with each of the given angles. So go ahead now and pause your video player, and we'll kind of work through these one at a time here. Let's try first 750 degrees. Go ahead and pause your video player and find an angle between 0 and 360 that is coterminal with 750. And when you're done, hit play and see how you do. I think it's going to benefit us to work through these one at a time. Okay, 750. So what I want to do is I want to kind of extract the full circle out of 750. So what I kind of do is I think, all right, let's take out one full circle, which would be 360 degrees, and see where we end up. So let's see, 0. Okay, so I took out one full circle, and notice I'm still at 390 degrees. So this is already still more than one. 390 degrees is still more than one full revolution. So let's take out another full circle here and see where we end up with. So we end up with 30 degrees. So what's happening here with this 750 degrees? It's going around the circle once. That's this 360 degrees. It's going to go around the circle again. Around the circle again. That's that 360 degrees. And then it's still going to have another 30 degrees left to travel. So it's going to travel right up to here. Here's my 30-degree angle right there. So this thing going around the circle twice and then traveling up to 30 degrees is the same spot or location as starting at 0 and traveling just up 30 degrees. So this thing is coterminal with an angle that is 30 degrees. Okay, let's try the next one. Go ahead and pause your video player now. Talking about radians now. In the same way we did this, you know, here I was extracting full revolutions around the circle in degrees, which is 360. Well, if we're talking about radians, a full revolution around the circle is just 2 pi. So same idea here, but now we're going to work with radians. So go ahead, pause your video player and try this one. So 11 pi over 3. I want to kind of take away full revolutions, which is 2 pi. but I also want to match my denominator here because I'm working with fractions. I want to match my denominator. So notice this is what I want to do. I want to have a denominator of 3, but I want this guy to be equal to 2 pi. Well, how about 6 pi? If I took 6 pi and divided it by 3, that's 2 pi. And that's what I want to work with here, is this 6 pi over 3, subtracting 6 pi over 3 away from this guy, because that will be subtracting the same as 2 pi. So let's see, if I took 6 pi from 11 pi, that's going to leave me with 5 pi over 3. Well, that's now smaller than 2 pi, so I'm now in just my first revolution around the circle here. And so we're going to go for another 5 pi over 3. So we're traveling by pi over 3's here. Well, these, remember, were pi over 6's. This was a pi over 6 travel. This here is a pi over 3 travel. That distance there, because if I take 2 pi over 6, that gives me pi over 3. So this is the distance I want to be moving here as I travel around the circle. That distance right there. I want to move 5 of those, because see, this is 1 pi over 3. I'm supposed to move 5 of these. So I would go, all right, there's one of them. That's 1 pi over 3. Notice this same distance again would take me to here. That'd be 2 pi over 3. So traveling this distance again, I'm now at 3 pi over 3. And that makes sense because remember, halfway around the circle is just pi. And so notice that's just giving us pi. But I want to keep counting by thirds here because I want to end up at 5 pi over 3. So let's see. 3 pi over 3, travel that distance again. Here's 4 pi over 3. Travel that distance again. There is 5 pi over 3. So there is my location for both 11 pi over 3 and 5 pi over 3. So those angles are coterminal, and they end up right here. Okay, let's take a look at C now. And this is kind of, this is a little bit tricky. Once you get used to this a couple times, it's not that hard. But there's a little bit of a learning curve here. So if you're not quite understanding everything that I'm saying as you go, keep trying here. And as we get through these problems here, as we keep going through these problems, you're going to get more and more comfortable with this. So question C here, now we're traveling in a negative direction. Remember, that means we're going to start right here, but then travel downward instead of up. That's a negative angle direction. So now we want to go negative 17 pi over 6. Well, this is going to be more than one revolution, so you're going to want to kind of do just like we did last time, kind of boil it down to what's left over after we kind of travel around the circle. So go ahead now, pause your video player and try this one. All right, so we've got negative 17 pi over 6. I want to kind of take out any full revolutions, which again is 2 pi, but in terms of 6, that would be 12 pi over 6. That's going to be 2 pi. So that, every 12 pi over 6, I travel is going to be one revolution around the circle. So what I'm going to do is I'm going to think about, again, dropping this down by 12 pi over 6, because that'll be one revolution. So I could think of this as, if I took 12 pi over 6 out of there, that's the same then as negative 5 pi over 6. Right? So if I travel 12 pi over 6 in this direction, if I went all the way around, I'd be at negative 12 pi over 6. So I take that out of there. I've already used that up traveling around the circle. If I take 12 out of there, I still have a negative 5 of these left. And I'm traveling by 6 now. So I would go, there's 1/6 in the negative direction. 2/6, don't get confused by this guy. Remember, that's a totally different measurement. That's a 45-degree angle here. So 1, set pi over 6, and then 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So I'm in this location right there. So this would be the location of negative 17 pi over 6. We went all the way around the circle once. That was 12 pi over 6, or I guess negative 12 pi over 6. And then what was left is negative 5 pi over 6. Now, notice we don't want to give this as a negative answer, though, because the instructions were to give a positive angle measure. This is a negative angle measure, so we wouldn't want to answer negative 5 pi over 6. We would be totally on the right track to do it, but that would not be correct according to what they're asking us. So what we want to do now is we want to start and travel to this location, but in a positive direction. So I want to travel around here. And so notice I'm traveling by 6. This is kind of in a location of 6. So I want to count by 6, just like I was doing in the negative direction. So let's count these up. So I start here. Here's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So in a positive location, this guy is coterminal with 7 pi over 6, positive. And again, this might seem a little tricky. Let's keep working them here, and you'll figure this out. All right, let's take a look at D now. Back to degrees, we're traveling negative 10.4 degrees. Okay, let's take a look now at question D. Negative 10.4 degrees. So go ahead now and pause your video player and answer that one. All right, so let's see. We're going to start here. We're going to travel negative 10.4 degrees. But remember, we want to write this in as a positive answer. So let's see. If I travel in a positive direction, I'd start here and I'd go all the way around. Almost 360 degrees, but a little bit short of 360 degrees. How far short? Well, 10.4 degrees short. So if I did this, 360 degrees, and I minused the 10.4 degrees, it would give me the positive location of this angle there. And so that's what I want to do. So 360 minus 10 would be 350, and then minus the 0.4 would be 349.6 degrees for the positive coterminal angle there. Okay, now let's take a look at question E. Again, we're traveling in a negative direction, but we want to list this as a positive coterminal angle. So go ahead and pause your video player now and answer question E. Okay, so we're traveling negative 11 pi over 3. So when I think about pi over 3's, all the way around the circle one time would be negative 6 pi over 3, because that's equal to negative 2 pi. So if I take a negative 6 pi over 3 out of that, I would be left with, let's see, 5 pi over 3. So I guess maybe what I'm saying here is I can take negative 11 pi over 3 and write it like this. Negative 6 pi over 3 plus negative 5 pi over 3. This is another way to describe what I'm doing here. The reason I'm doing this or breaking this part out is because that's equal to 2 pi, which is 1 revolution on the circle. So let's see. If I'm going to travel this whole thing now, the first thing I'll do is I'll travel this negative 6 pi over 3, which would be moving in the negative direction all the way around one time. Okay, so I've traveled all the way around negative 6 pi over 3. Now, the next thing I'm going to do is try to travel this negative 5 pi over 3. Well, that's almost all the way around again, because negative 6 pi over 3 would be all the way around back to here. So you can think of this as just as going to be one of these pi over 3 short of all the way around. Well, one of these pi over 3 short is just right here. So that's our location that we're going to end up at, and sometimes I think it's easier, like I did here, to just count backwards one of these thirds, one of these pi over 3's backwards to get to that spot. But if we didn't see that, we could go around the forward direction as well. So I'm counting by thirds, negative 5 pi over third. So I'd be 1 of those, 2 of those thirds, 3 of those thirds, and again that's pi halfway around, 4 of those thirds, 5 of those thirds. So either going in the negative direction here or just realizing we're just going to be 1/3 short to get to that spot. Either way it works. So now let's see where we are now in a positive angle direction. Notice all of our angle directions were moving negative. So really this is what happened here. Let me connect these. So this negative 11 pi over thirds, originally we went all the way around the circle once, which was this negative 6 pi over 3. Then we start traveling around the circle again. We get almost all the way around and stop here. Now, how do we get to that location in a positive direction? Well, we start here and come up this way. Well, that is just pi over 3 moving in that direction. So the positive coterminal angle here is just going to be pi over 3. Okay, let's try question F now. Negative 855 degrees. So go ahead and pause your video player and answer this one. All right, negative 855 is equal to, well, let's start taking 360s out of that, because traveling in negative 360 will be one complete revolution. So I could think of this as, gosh, how many 360s could I add up in there? Well, if I did one of those, I'd be at 360. I still have some to go. 2 times around the circle would be twice 360, which is 720. Negative 720. Now I'm getting closer, right? So we could think of this negative 855 as negative 720, 2 times around the circle, plus some negative angle left over. Let's see what negative angle would be left over. 855 minus 720 would be 531, 135 degrees. So negative 135 degrees. That's the way I want to think of this negative 855. It was 2 times around the circle in a negative direction, plus this little bit left over. So that's what I'm going to do here. I'll start here, and I would go 1 time, 360, that would be negative 360, negative 720. Now I want to keep going another negative 135, which we know is 90 plus 45. So right there, that's a negative 135, and I just thought of that as 90 degrees plus 45 more is negative 135. So there's my spot. Let's try to figure out now how we get to that spot moving in a positive direction. So let's see, I'd be first 90, 180 to get to there, and then 180 plus another 45 degree angle to get there. So let's do that. 180 to get to this spot, plus 45 more. 225 degrees. It looks like that thing was coterminal with 225 degrees. All right, last one here. G. Negative 21 pi over 4. Go ahead and pause your video player now and answer that one. All right, negative 21 pi over 4. So let's think about pi over 4s. How many pi over 4s does it take to make 2 pi? Because that's a full time around the circle. Well, the answer then is 8 of those, right? So it takes 8 of those guys to make a full revolution. So we want to kind of take negative 8 pi over as many of these out as we can. Negative 8 pi over 4 is out of there. I think we can take 2 because 8 plus 8 would be 16. 1 more 8 would be 24. So we just want 2 of these. So we're at 16 right there, negative 16 pi over 4. We would need 5 more to get to 21. So plus negative 5 pi over 4 to get to 21. Let's see, 8, 16 plus 5, 21. Okay, that's good. So this is 1 full revolution, 2 full revolutions. So what we've done here is we're going in the negative direction. There's 1 revolution, 2 revolutions. And now we're going to go negative 5 pi over 4 here. So let's just count them up, going by pi over 4. So here's 1, 2, 3, 4, 5. There's negative 5 pi over 4. So here is our location. How do we get to that location in a positive direction? Well, we're counting by pi over 4, starting from the positive side. There would be 1 pi over 4, 2 pi over 4, 3 pi over 4. So this thing would be coterminal with 3 pi over 4.